Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on loss of energy in the pipe flow. So, in our previous lecture also, we have discussed a problem similar to loss of energy, and there we have implemented the Darcy-Weber's formula, or you can say the losses due to the friction. So, this problem also similar kind of the previous one, but slight different is there. Here we need to implement or we need to apply another one formula, that is Chezy's formula here. So the question is, calculate the head loss due to friction in a pipe of diameter 300 millimeter and length 50 meter, through which water is flowing at a velocity of 3 meter per second by using Darcy formula and Chezy's formula, for which C equal to 60 and take nu for water equal to 0.01 stokes. So this is kinematic viscosity. So the question is very simple. We need to find out the head loss. So for that, first we will write what are the data given in this question, and then we can see like what are the formula can be implemented for this to find out the head loss. So in the data given, we can write first one. The diameter is given 300 millimeter. So this is nothing but we can write 0.3 meter. And the next is the length is given L given 50 meter. And through which the water is flowing with a velocity of V equal to 3 meter per second. And the constant value, Chezy's constant value C, we need to consider 60, and the new value, kinematic viscosity, this is given 0.01 stoke. So this one we can also convert into meter square per second. So this one I can write 0.01 into 10 to the power minus 4 meter square per second. Anyway, these are the values are given in this question, and here what we need to calculate. So head loss by using Darcy formula and by using Chezy's formula. So first point is, let's write down, by using the Darcy formula we know that the head loss HF equal to 4F LV square by 2dg. So in this equation, if you see, all the values are given here except the F value, the coefficient of friction value F. So F can be identified by using this relation of Reynolds number, because it is a function of Reynolds number. So first we need to identify Reynolds number, then after that, based on the Reynolds number value, we can see whether the flow is laminar or turbulent, and based on that we will implement the friction factor formula. So we know that again we can write Reynolds number equal to rho Vd by mu, or we can write C equal to also Vd by nu. So V is given here 3 meter per second, and this is 0.3 diameter, and nu is given 0.01 into 10 to the power minus 4. So now if you divide this, so we'll get here value, we can get the value of 9 into 10 to the power 4, because 3 into 0.3 and divided by 0.01. So this means 90 into 10 to the power 4. So 90 into 10 to the power 4, this is the value of Reynolds number. So this value indicates that the flow is turbulent. Okay. So now, though the flow is turbulent, we can apply the formula for friction factor equal to 0.079 and divided by Re to the power 1 by 4. And we can get the value, very small value, we'll get it here, because 0.079, and this one we can write 9 into 10 to the power 5 to the power 1 by 4. So this one will get it. Let's see. So this is 90. Again, what I'll do, 10,000 to the power 0.25. So 30.8. So this is nothing but 0.79, and this is 30.807. Anyway, this one. So what we'll get here, let's divide this 0.079 divided by 30.8. 0.00256. So the F value what we got here, 0.00256, very small value. Now same thing we can put it in the equation of HF, and we can find out the value of head loss due to friction. So this is 0.00256 multiply of L is given 50, and this is V square. V is nothing but 3. So 3 square 9. We can, this is 3 square, and divided by 2 dg. So 2 into 0.3 into 9.81. So now we can again calculate it here. So multiply of 4, again multiply 50, again multiply 9. This equal to divided by 2 into 0.3 into 9.81, bracket close, 0.784. So now we got the value 0.784 meter. So this is the head lost. This is the head lost in the pipe flow. So due to friction by using Darcy formula. Okay, by using this formula. Now again one more thing is given, that is second part. By using Chezy's formula, we need to calculate the value. So we know that Chezy's formula is nothing but the V equal to C into root over of M into I. See, by using this formula, again we need to find out the HF value. But in this formula, if you see, there is no HF is there, because here the value of M we need to consider. We have considered the value of M equal to D by 4. Okay, and the value of I equal to, we know actually, I equal to the head lost to the power per unit length. Okay, so first of all we need to find out the I value from here, then we will go for this head loss calculation. So here M equal to, you can write D by 4, D is equal to how much, 0.3. So 0.3 divided by 4, so this will be near about 0.075 meter. So now put the value, velocity is given 3, and Chezy's constant C equal to 60, and this is root over of 0.075 into I. Okay, now what I'll do here, I can write this is 3 by 60. Okay, 3 by 60 square directly, right, equal to this side 0.075 into I. Okay, now because this 60 I have taken to this left hand side, and after that I have taken this removed this square root, and I have taken the square of this left hand side. So now what I can do here, so I equal to, we can write, just calculate this value, 3 by 60, 3 by 60, that is 0.05, 0.05 square. So this one, okay, this one, and a multiply of, no, I equal divided by this one, then divide by 0.075. So it's 0.00333. We got this, yeah, 0.00333 we got. Now we can write this 0.0333, all value we got. Now next thing is we need to find out the head loss. So here head loss equal to, I can write this I into L. I into L. So I equal to how much? Here just we calculated 0.0333 into 50. So just multiply of 50. Here you can get 0.166. So 0.166 meter. So this is about the head loss due to the friction in the pipe by using Chezy's formula. Now all this value we can see. So if anything is missing here, we can just check it. So let first do from starting. 0.3 divided by 4. So 0.075. Okay. And this side is given 3 divided by 60. Correct. So 3 divided by 60. 3 divided by 60. So whole square. So this is into 0.05 or square you can give, same thing will get. Now again, yeah, so this value then divided by 0.075, 0.033, yeah, correct only. So now this one will be multiplied with 50, multiplied with 50, 1.666 we got. Okay, so this value will be get 1.666 meter. So now you can see the difference. Similar things we have just done, head loss for both by using this both formula. So here we can get the value of head loss 0.784 meter, but in the case of Chezy's formula we got 1.66 meter. So this is all about this problem. So very simple question. Only you need to identify the data given from this. Then after that, if you know this formula, you can easily implement this formula and find out this value. So this one already you have derived in our previous lectures, this formula, and this one we have found from our previous derivations. So I hope you understand this problem. If you are having any doubt and query related to this, you can give a comment on the comment box. Thank you.